Now let's go back. Let's come back to preferential attachment. Okay, example of power law in the real world. I have actually shown you earlier that those are examples that obey power laws, but there are others as well. Well, if you think about that, this left and this right, right? This right, the airline flight network, you can see that there are hubs that occur in the network. That is, there are mostly connected players, and if you have those mostly connected players, mostly connected the airport, then you would have this power law distribution, this United Airlines flight network. On the left hand side here, you got the road network. Actually, road network is not power law because you can imagine that the largest connection might be 5 juncture between 5 roads coming together, right? You cannot have more than that. So it's not obeying power law. So there are networks that would behave like power laws. There are networks that not behaving like power laws. Why is that? One might be because of the constraint, the physical constraint. Another might be that there are actually another different principle that govern that type of network. So it doesn't mean that you have to obey this principle all the time, but in some case it might be this one, in some case it might be another, just like when you talk about quantum, right? Okay, let's not move on that. So in the former, you have the node would have similar degree, like you would have intersection of 4. Each intersection would contain 4 degree, because if you have like this one, you can have like a fork load, or you can have like 3 degree of 3, like that. Okay, or if you want to model the place in the graph on the left hand side, it can have like just 1 degree going in, for example, or it can be in the middle of the road, depending on the thing that you want to model. So this is an example of power laws, right? So to model network, we need to find a way that we can simulate power laws, simulate a network with power law. Knowing that would allow us to create, you can think about games, allow us to create games that or create a simulation of real world connection that growing out with specific characteristic by those parameters that you have optimized. Okay, we want those networks to contain produce hubs and have long tail, right? Long tail node with lower degrees, like this one, right? The one that is here have high degree, and the one that are here have low degree. I should have something like draw it and then having done that, but that needs editing. I'm not going to do that. Okay. Okay. So yeah, these are another example. Like some of the law have been posted. Some of these you may have seen, like Lotka law. Lotka postulated in 1926 that the authors in index of chemical abstract is power law, right? In terms of the index number of page occurring. That might be true. I use law about city population, right? Following power law as well, right? Just a lot of city would have low population, probably high city, just a few have high populations. Shift law, this one you may have seen, right? Because with this class is half of the class is about text mining. So talk about that you have the frequency of word. It's actually inversely proportional to the rank in frequency table. Right? So the top word would have large number of occurrence, and it will decrease exponentially. Right? Simon has explained that power law is actually common in various phenomenon, and Pareto talk about Wales distribution also obey power laws.